Hey guys, is it going? Yeah. Hey guys, this is Miss Bendon. We're going to talk today about simplifying radicals. So by radicals, we mean this little symbol here, which when there is no number floating on it is a square root symbol. And so we're being asked for the square root of 25, and you may just know that off the top of your head, or you can pop it in your calculator. The square root of 25 is 5, and the reason for that is that 5 times 5 equals 25, and we're looking for the number that could multiply times itself to get to 25. So when we take the square root of something, we're doing the opposite of squaring it. So square roots or radicals are the inverse operations of exponents. So when we say that the square root of 25 is 5, one way we could do that by hand is we could break down 25 into 5 times 5. 5 times 5 is 25, so I've just rewritten this as sort of the factors. And then if I think about it, 5 times 5 is 5 squared. So I've got the square root of 5 squared, and those two symbols cancel out because they're inverse operations, and I'm left with just 5. And we can use that strategy to simplify radicals even if they aren't perfect squares. So a perfect square is a number like 5 that can be multiplied by itself to get or is the result of multiplying by 5 by itself, 25. So some perfect squares are 2 times 2 is 4, which means the square root of 4 is 2. 3 times 3 is 9, which means the square root of 9 is 3. 4 times 4 is 16, so the square root of 16 is 4. And so those are our perfect squares. But not every number is a perfect square. Not every number has one single integer that multiplies by itself to get to it. There is no number you can multiply times itself to get to 32. So what we're going to do is we're going to break 32 down into its factors, just like we could break 25 down into 5 times 5. So I'm going to break 32 down into 2 times 16. And then 2 doesn't break down any further. 2 is a prime number, so I'm done breaking that down. 16 I can break down into 4 times 4, and then I've got the radical of 2 times 4 times 4, because 2 times 4 times 4 is 32, or I've got the radical of 2 times 4 squared, and because I've now got the square root of a square number, that 4 is going to move outside the radical. But that 2, which didn't have a square on it, this 2 here, is going to be left inside the radical. And so the square root of 32 breaks down into 4 radical 2. So what we're doing when we do this is we're breaking numbers down into their factors, and we're looking for things that can be squared. We're looking for numbers that we can get repeats of, basically. And you can break factors down in whatever order you like. I'm looking for the highlighter. But once you get to a repeat, once you get to something times itself, you can take that and you can move it outside of the radical symbol. So let's try this with another one. Let's break down 40. So you could do this however you wanted. You could start with 4 times 10, or you could start with 8 times 5. I'm going to start with 4 times 10. And then 10 breaks down into 2 and 5. And both of those are primes. Nothing is repeating yet, so that doesn't break any further. 4, I already know, is going to break into 2 times 2. So 2 times 2 is going to give me a pair, and I can move that 2 outside the radical because I had a pair of 2's. And then once I've moved those outside the radical, I'm left with this 2 times 5, and neither the 2 nor the 5 has the pair. So the 2 times 5 is staying inside the radical. And then I've got 2 times this radical of 2 times 5 is just 10. So radical 40 simplifies to 2 radical 10. All right, guys, so try these on your own, and then we'll go over them. Try simplifying radical 75 and try simplifying radical 24. So radical 75 is going to break down into, let's see, I would start with that one, just because I know money math off the top of my head. I know that 3/4 is 75 cents. I know that 3 times 25 is 75, so that's a nice starting place. 3 is prime, so that one's done. And then 25, I'm happy with. I already know that it's a perfect square. It breaks down into 5 times 5, so I'm going to have that pair that's going to move outside the radical, which means that I've got a 3 left to go inside the radical, and I've got 5 radical 3 is what radical 75 breaks down into, and then try radical 24. I'm going to start with 2 times 12. You'll still have gotten the right answer if you maybe started with 3 times 8. And then 2 is prime, so I know it doesn't break any further. 12 becomes 3 times 4. 3 is prime, so it doesn't break any further, but I've got that 4 that I know is going to break into 2 times 2. So I've got my pair. I've got a pair of 2 times 2, so that brings a 2 outside the radical. And then I'm left with this 2 and this 3 inside the radical. So I've got 2 times 3 is 6. And I've got 2 radical 6 as the simplified version. Okay, weird case number 1, radicals on fractions. Can we simplify this? We can, and there are a couple different ways to think about what mathematically is actually happening here, but to me, the easiest way to think about it is to go ahead and say that the radical of 4/9 is the same as radical of 4 over radical of 9, which means that we can then just approach the numerator and the denominator separately. So what is the square root of 4? It's 2. And what is the square root of 9? It's 3. So the square root of 4/9 is 2/3. And then weird case 2. We've got a fraction that is 3 over radical 2. And radical 2 can't be simplified any further because that 2 inside the radical doesn't break down. It's already a prime number. There's nothing we can do to that. But for whatever reason, mathematicians say that a number is not fully simplified if it has a radical sign in the denominator of a fraction. So we have to move that denominator up to the numerator. And here's how we're going to do that, is we're just going to multiply by the square root of 2 over the square root of 2. So I've got the square root of 2 divided by the square root of 2. What's anything divided by itself? 1. So I'm really multiplying by 1 because the square root of 2 divided by the square root of 2 is 1. And if I multiply by 1, I'm not changing the value. So I'm allowed to do that. And then when we multiply fractions, we just do top times top, bottom times bottom. So 3 times radical 2 on the top is going to be 3 rad 2. And then on the bottom, we've got this radical 2 times radical 2. So we've got a square root of 2 times itself. So square root of 2 squared. Square root and square are inverse operations. They cancel. And so we've got 3 radical 2 over 2. And that means that we've now successfully moved that radical sign into the numerator of our fraction. And we consider this to be fully simplified. All right, guys, you have a delta math to practice simplifying radicals, and you'll come back and do some more interesting things with radicals in the next video tomorrow. Bye!